Hello, in this video we'll be discussing voltage and current division as well as a new circuit element, the potentiometer. So to start with, we'll look at voltage division. Draw our circuit out here. Got a source and two resistances in series, R2 and R1. Now, one little note on notation here. When I draw these two leads out and I put that circle at the end of them, I'm saying that there's an infinite resistance there. So really, what this looks like is just another resistor, but it's infinite. And what do we know from that, from Ohm's law? Well, we know that there will be no current flowing across there. And I do that because I want to know V out. I want to know how much voltage I get across that resistor. And what would I want then? Well, if I want a fraction of the input voltage. So in this case, all I have to do is set up the circuit in terms of Ohm's law. So I know first from last video that my equivalent resistance is just R1 plus, getting in the way of my recorder here, let me drop that down, Req equals R1 plus R2. Okay, got that. How about the current coming out of it? Well, we can figure that out too. We'll call our current I, input voltage V naught. Let's differentiate that. It's called V in. We won't get it confused with V out. So then I have I equal to V in over my equivalent resistance, R1 plus R2. And V out is just that current, since we know none of it's going to flow into the infinite resistor branch there. My V out is just going to be I times R1. Now all I got to do is sub that in. I get this nice equation. V out equals R1 times, divided by R1 plus R2 times V in. And you can check this real quick. How about our units? Alright, we have a resistance over a resistance, so that's going to be unitless, times a voltage. Okay, so we get a voltage. Does a voltage equal a voltage? I sure hope so. Alright, and then we have a voltage division. V out is going to be some fraction of V in, and that fraction will be whatever relationship these resistors have with one another. So if I wanted V out to be very close to V in, I would make R1 much, much larger than R2. If I wanted it to be smaller than V in, I'll do vice versa. Make R2 much larger than R1. Alright. Now, the potentiometer is a device that allows us to change the resistance of a resistor, say. It's basically a variable resistor. A circuit element we draw like this, except it's got an arrow on it. Sometimes you might see, in general, something like that. That arrow across the element just means it's variable. So in this instance, if I wanted to change the relationship between V out and V in, I would use a potentiometer here for R1. I'll be able to move it from very small to very large compared to R2. And that way I'd be able to vary my V out. And let's look at this in the circuit, say. So in the notes, this is the same circuit we have at the top of the page. Just going to draw it a little bit differently. Familiarize yourself with the differences between these two and how they're drawn. As I said before, as people, the electrical engineers are very lazy. So in the notes, there's a whole bunch of lines missing. And here, put it in a bit more familiar form. Nonetheless, they are equivalent. So here, I have my wiper right there. And this wiper is this third arm of this potentiometer that determines what percentage it's going to have of its resistance. So if I had like a 10 kilo ohm potentiometer, that means that I could vary it between 0 ohms and 10,000 ohms. If I'm halfway, I'm going to have, you guessed it, 5,000 ohms. And what I've attached its third leg to, this wiper here, is a load, 10 kilo ohms. And in the previous example, I was talking about how we could vary R1 and R2. Well, that's how we do it right here. Let's look at the equation for this. So if we do this out, we have, let's say, instead of 10K, let's give it an infinite resistance. And then what we have is identical to the first example. So we can follow the same steps. Alright, so R1 AR over the total resistance. A times R plus 1 minus A times R. Alright, so now you're asking, what the heck is A? Well, A is a value from 0 to 1 that tells us what percentage that wiper is at, what it's set to. So if you look at this, if A is 1, that means that the first resistor is going to be 0, and the second resistor will just be R. So this is going to be R. If we look at our equation here, we solve this out, okay. R times 1 is R. R times negative A is negative RA. That cancels out on the denominator. We get AR over R. So what this really equals is A times Vn, where A is that constant that tells us what percentage our potentiometer is set to. So think about your car stereo. If you have an old car like me, you've got a nasty little knob on there. You twist it one way, volume goes up. Twist it the other way, volume goes down. All that is a potentiometer. When we twist it all the way to max, we're setting A to be 1, something very high. And in that case, our V out is going to be equal to our V in. Now, when the cop pulls me over for speeding, gotta turn it down, and that A goes to 0, and my V out is equal to 0 times V in, 0. So, handy little device, variable resistor, allows us to put a lot of different values into our voltage dividers. One thing to note is this infinite resistance. We don't have a real infinite resistance. We can get really, really high resistances, but the important thing is relative. So in the notes, there's a graph on comparing whether that resistance, that infinite resistance, call it RL, resistance of the load, how close it is to the resistance in the potentiometer. And essentially what we want is that RL to be very, very big, because otherwise the A term, the gain, becomes non-linear. And that's not fun for anybody, because that invalidates a lot of the tools we use to analyze them. Okay, so how about current division? Well, let's set up the circuit. We've got two resistors here in parallel, R1, R2. We've got two branch currents coming down, I1 and I2. We've got some voltage being set by the source, some current coming in. And what we want to know is how much we can pull off of that, say, R2. And notice we've got an example of 1%. So let's use that. So let's set up our equations first. We know the voltage, Vn, is going to be equal to I1 times R1, and also equal to I2 times R2. And we can rearrange this side of the equalities to look like I2 equal to I1 times R1 over R2. And if we want 1%, we want I2 to equal 1% of I1. Well, kind of looks like we've already got this solved, right? Because this is just going to equal that. So in this case, we can just pick what we want R1 and R2 to be. And the other will follow suit. So let's say if R2 is 10 kiloohms, well, what does R1 need to be? Or if we pick the opposite, we can say R2 is 1 kilo ohm. If we have any notes, all we got to do is multiply that by 100. A lot of problems we'll have will force you to pick. So if I just give you this problem and I say, you know, I want 1% off this, you could say, all right, well, I'm going to make R2 equal to 5 kajillion ohms. That's fine, as long as your relationships are satisfied. You can pick whatever you want.